Hello class, welcome to this lesson for 7.1, angles of polygons. So our central question is as follows. So how do we use theorems about interior and exterior angles of polygons to solve problems? Okay, so we're going to be talking about some angles for polygons. So this unit is all about polygons, and we're going to focus on interior, exterior angles in order to solve some problems. So what are the interior angles in a polygon? What are the exterior angles? What do these add up to? These are the questions that we're going to be concerned with. So let's learn the interior angles of a polygon. So remember, a polygon is a closed figure where you have these sharp points, right, called vertices. So, for example, a pentagon will be a polygon, 1, 2, 3, 4, 5 sides. Something that would be circular or curvy is not a polygon, because even though it's closed, it doesn't have any vertices. So we're looking for things of that sort. Now, if you have a polygon, you can connect any two any two vertices that are non-consecutive. So you got two non-consecutive vertices within a polygon. So, and that's known as a diagonal. Okay, so diagonal, it's an important term, is a segment that connects any two non-consecutive vertices. So this would be an example of a diagonal here. Oops, let me rewrite that. The diagonal there, as well as here. So those are both diagonals. Notice it goes from one to the other, but it's not next to each other, so it wouldn't be connected to PQ, right? It would be only connected to like PR or PS. Those are ones that are non-consecutive. That's what it means by non-consecutive. So those are diagonals. And notice that the diagonals separate the polygon into triangles, right, when we do this. In this case, into 3 triangles. So the idea with this is that because you can break this into triangles, right? So you can break this pentagon into triangles. There's 3 triangles that can be formed. And we know that the sum of the angles in any triangle is 180. So in other words, for this triangle, we have 180 degrees for all 3 angles. For this triangle, we have another 180. And then for this one, we have another 180. So that means we have a total of 3 180s, right? And so that means that the angles inside this pentagon here, the angles add up to 3 times 180, or in this case, 540 degrees. And that's how it works. You take any polygon and you draw these vertices coming from one point, as many vertices as you can, and you form triangles, and then these triangles add up to 180, each of them, and you get your total. And so notice that there was 5 sides in this pentagon, but we ended up multiplying by 180, not 5 times, but 3 times. And so in other words, we subtract 2 in order to get 3, and then we multiply that by the result of 180, which is per triangle. And this is the polygon interior angle sum theorem. And this is listed in general as follows. Theorem 7.1, polygon interior angle sum theorem. The sum of the interior angles, they have to be interior, of an n-sided convex polygon is as follows, right? So let me just box that because that's a formula. So the sum is equal to n minus 2 times 180. This mirrors exactly what we did here, right? Where we had 5 sides, and so n is 5. 5 minus 2 is 3. 3 times 180, which is exactly what we had here, right? Okay, and there is the theorem. There's your first theorem for interior angles for any polygon. This even works for a triangle as well. So, a little tip here. This is a good study tip, and I would highly suggest you emphasize this. Know the names for different polygons. Okay, so if you have 3 all the way to 12, know those names. Three sides is a triangle. Four sides is a quadrilateral, like for example, a square or rectangle. Five is penta. So five is penta. Three is tri. Four is quad, like cuatro, like the Spanish word cuatro, four. Six is hexa. It's kind of like hexa. When you think of hexagon, you think of six sides. And then hepta is like septa. Septa is seven, and but they use an H instead of an S, right? And then octa, like an octopus, eight sides. Nona kind of sounds like nine, nina. And then deca, like a decade, right? 10 years. And then you have, they call this an hendecagon. I usually call it an undecagon. So undecagon, undecagon. Un means like uno, one, and then deca is 10. Okay, and then do is like dos, like in Spanish, two, and then deca is 10. So 2 plus 10 is 12, right? So do decagon. And then you have n for an n-gon. So if you have anything more than 12, we can just say like 13 gon or 100 gon, so on and so forth. But just know these names. All right, example 1. Find the sum. It says find the measure of each interior angle of this pentagon. So here we have 1, 2, 3, 4, 1, 2, 3, 4, 5 sides. So we have a pentagon, right? 5 sides. So in this case, we're going to do, using this formula right here, 5 minus 2 times 180. And so that's 3 times 180, which is 540 degrees. So we know that each of these angles has to add up to 540 degrees. All right, and then we're going to basically add these up to and set it equal to 540. And we're going to continue this on the next page here. All right, so it says find the value of x. So again, we're going to add up all those angles that we saw in the previous diagram. So notice there are 1, 2, 3, 4, 5 angles. All right, so let's combine these. Combine the x coordinates, or the variables rather, the variables x. So 2x plus 2x plus 3x plus 3x. All right, so that's 6, 8, 10. So we got a total of 10x. And I'm going to show my work here. So we got 10 x plus, and so 10x plus 142 equals 540. All right, and then we're going to subtract 142 on both sides. We get 300. So in this case, we get 358. Okay, and then we're going to divide. Oops, I forgot to add 142 and 14 and 14. I forgot about these two 14s. Okay, so let's add these two together. I forgot to add these. So we got 28 plus 142. So we got 28 plus 1. So we'll do 28 plus that. So that gives us 170. So this should actually be 170. So let me correct that. All right, so we subtract 170 on both sides, not 142. So obviously it's going to change this number. So we have, this turns into 370. This is actually a nicer number. So then we divide by 10. And so we get x equals 37. All right, so this is saying that each of the, we know that x is 37. And remember, we are trying to look for angle J, angle L, angle H. We're trying to look for each angle, right? So we're going to plug it into each of those angles. And if you go back to the previous picture, we already know that J was 142. So I'll show you that right here. And then we're going to plug in 2 times x, 2 times x, 3 times x plus 14, 3 times x plus 14. Okay? So that's what we're going to do. All right, so we said that J was 142 degrees. So that's that one. And then this one is 2 times 37, because x is 37, which is 74 degrees. This one's 3 times 37 plus 14. So that is going to give you 125 degrees. And then again, this is the same thing, 2 times 37 or 74 degrees. All right, so that gives you all the angles that we're looking for, all 5 angles. All right, so go ahead and try the following check below, and then we'll go over it. Okay, so just, hopefully you paused the video and tried the problem, or, so we can give it a try. But we have 1, 2, 3, 4, 5, 6. We have 6 sides here, so we got a hexagon. So we know that n is equal to 6 here. And so we know that from the polygon interior angle sum theorem, we could do 6 minus 2 times 180. That's 4 times 180, or 720 degrees. So we know that each of these angles have to add up to that, right? So that's exactly what we're going to do. So we're going to add up each of these. So we got x plus 2 plus x minus 8 plus x plus 7. Plus x minus 3 plus x plus 6 plus x minus 4. And we know that that has to equal to 720. All right, we're going to combine our like terms here. So we got x plus x plus x. So there's 1, 2, 3, 4, 5, 6 x's here. So we got 6x. We got 2 minus 8, negative 6, plus 7 is 1, minus 3, negative 2, plus 6 is 4, minus 4 is 0. So basically these all cancel if I combine them. So we just have 6x equals 720. Divide by 6 on both sides. We get x is 120. So 6 goes into there 120 times. All right, so then now what are we trying to look for? Are we trying to look for x? Well, no. We're trying to look for e. And what is angle e? Well, angle e is x plus 6, right? So we got to plug it into there. So we're going to plug this in, angle e. So the measure of angle e is x plus 6, so 120 plus 6, so 126 degrees. All right, and that's my final answer, so I'm going to check that. Okay, so let's look at example 2 with the floor plan. Penny is building a house using a floor plan that she designed. What is the measure of angle ABC? So we're looking for this angle right here, so this is the question mark. Notice that they're talking about a regular polygon. So what is a regular polygon? A regular polygon is a polygon that where all the sides are congruent. So you can see all the sides are the same, and not only that, but all the angles are the same. So we're going to actually draw a picture of this in the next page, just because we don't have any room on this page necessarily to focus on that. Or we do, but we're going to actually do it on the next page, and I'm going to emphasize that then. But just for now, we know that the sides have to be the same and the angles have to be the same as a result. Okay, and that's what we refer to as regular. And we know that since we have 6 sides, we know that n is equal to 6, right, for this hexagon. And so we can use the polygon interior angle sum theorem here. So what is the task? What are we looking for? What is the measure of angle ABC? So we need to find measure of angle ABC, right? That's what we need to find. That's our goal. And how can you find answers to these questions? Well, first off, we want to use a theorem, the theorem that we just recently talked about, right? Describing the interior angles. So use a theorem describing interior angles of a polygon. In this case, this polygon is a hexagon, right? But we're just going to use a theorem describing that in general. And then describe how we're going to do this. So how are we going to do this? So we're going to use the polygon. We got to know the name. Polygon interior angles sum theorem. Okay. And we're using this to find we're going to add up, to figure out all these angles to see what they add up to find the sum of all the interior angles all right, of the hexagon. So in other words, n is equal to 6, right? All right, since the hexagon is regular, all angles are congruent. So if we know that the sum is a certain number, then we could just divide by 6, and that gives us the one that we want, right? So all angles are congruent, so divide the sum by 6. All right, in this case. So that's our approach. That way all the angles are the same. Okay, so let's look at the step 3 for the approach. Okay, so now what is the solution, right? So what are we going to do? What's our strategy? So we're going to write the equation that we're going to use. So again, we have to write do all 6 angles. I'm sorry. So the first one is angle AFE, and then we have FED, and then EDC, DCB, and CBA or ABC, right? Same thing. So we're going to list out all of those, okay? So one of them is FAB, and then we have, of course, we have the ABC angle. We have the BCD angle. Again, go back to refer to your diagram so you know why we're using these angles. CDE, DEF, and EFA. So that looks like 2, 4, 6 angles, and that has to add up to, now how do we know? Well, it has to add up to n minus 2 times 180, where n is equal to 6, right? So we got 6 minus 2 times 180. That's 4 times 180, which is 720. So the sum is 720. And so now we're going to solve this. Now these angles are all the same. So really it's just going to be 720 divided by 6, which is 120 degrees. Okay, so that means each of these angles adds up to 120. So in other words, we come up with a generic formula. Okay, so this is the generic formula for a regular polygon for interior angles. Okay, so this is for interior angle for each. So for each interior angle. Okay, so if I want to get the formula for each interior angle, then I'm going to use the following formula. I'm going to use this formula, n minus 2 times 180, and then I'm going to divide that by the number of sides. So we're going to say x is the interior angle. Okay, so for example, if I had a polygon where it's regular, and then this is x, right? Each of these angles is x. So that angle is n minus 2 times 180 divided by n. Okay? And there's my formula that I want to use. Okay, so hopefully this makes sense. So let's look at the next thing here. All right, so let's look at the check. So go ahead and pause the video for a second and see if you can try what we just did. Okay, so hopefully you paused it and so you can try it. So here we have he wants to have a pond with a deck of equal width around it. So this is the deck, and it has the same width all the way around. So it's a regular, in this case 1, 2, 3, 4, 5. So n is equal to 5. So it's a regular pentagon, 5 sides. The measure of the angle of the pond formed by 2 sides of the deck. So we want to figure out what that angle is, right? And each of these angles has to be the same because it's regular, right? We're just going to find one of them that gives us the rest. Okay, so using that formula, x is equal to n minus 2 times 180 divided by n. But we know that n is equal to 5, so we can just plug that in. So we have 3 times 180 divided by 5. And we know 3 times 180, that's 540. Then you can divide that by 5. You get 108 degrees. All right, so your final answer is 108. All right, there's our check. So let's look at example 3, the next type. Identify the polygon given the interior angle measure. All right, so the measure of an interior angle of a regular polygon is 144 degrees. Find the number of sides in the polygon. Okay, so first off, we know the formula is x equals n minus 2 times 180 divided by n, right? And so where n is the number of sides, which is what we're trying to look for, we need to find the number of sides. So they're looking for n, so n is the question mark, right? But we do know that the measure of the interior angle is 144, so that's my x in this formula, all right? So x is equal to 144. And so we can just plug that in here, and then multiply both sides by n. So I'm going to plug that in here, so x is 144. And then I'm going to multiply both sides by n, right? So that way I can get rid of this n on the bottom. So I get 144n equals n minus 2 times 180. And so you can really see that this is this step right here for this equation. So we can write 144. And then we're going to distribute. So we're going to distribute the 180, and we're going to show the rest of our work here. So we got 144n equals, so 180 times n, this is the distributive property, and then minus 180 times 2 is 360. And we're going to add 360. Actually, what we're going to do, scratch that. We're going to subtract 180n on both sides. So we're going to move this over here. So this gives us negative, in this case we get negative 36. Let me just do that over here. Negative 36n equals, this cancels. We got negative 360. We can divide by negative 36, and that gives us n. So n is equal to 10 here. All right, so n is 10 if we solve it. So the polygon has 10 sides, so it's a decagon, and it's a regular decagon. All right, guys, again, try to pause the video, please, so you can try this problem using the same method. All right, so hopefully you paused it and tried it. So here you go. The measure of an interior angle of a regular polygon is 150. Find the number of sides in the polygon. All right, so we got x is 150. Okay, so let's do that. 150 equals n minus 2 times 180 over n. You move the n over to the other side. And then we'll distribute the 180. Okay, so we get 180n minus 360. Just to skip a few steps, but just the same idea here. Subtract 180n on both sides. So we get negative 30n equals negative 360. Divide by negative 30. And so really you get, so 3 goes into 36 12 times. And then, so yeah, so it's going to be n equals 12. All right, so the polygon has 12 sides. Remember that that is referred to as a dodecagon. All right, so let's look at the back, the last page for the lesson. So here we have an exterior angle. So we're looking at exterior angles. So now this is a good time to talk about convex versus concave. We have the word convex here. We'll talk about that in just a second. But here we got the sum of the exterior angles of a convex polygon is 360. So this is like part of the formula, so I'm boxing that. So again, so the sum is equal to 360. Here's an example. These are the exterior angles, right? So these angles all add up to 360. Angle 1 plus angle 2 plus measure of angle 3 and so on. But let's talk about what convex is versus concave. There's two types of polygons. There's convex versus concave. But there's also regular versus irregular. Let's briefly do an aside here and talk about the difference between those two. So let's see, concave versus convex. Okay, so let's look at those two examples. So let's look at a pentagon. So we know that a pentagon has 5 sides, so that would be an example of a pentagon, okay? Now, this is convex because the sides stick out. So notice that this side sticks out like an arrow. This sticks out like an arrow. These vertices stick out like arrows, right? And that's what we mean by convex, right? It sticks out. Now, imagine this here folding in on itself and collapsing. Instead of sticking out, it's actually going to go in. So if we did that, it would look like this. So now this side is going in instead of out. But the rest of the sides are going to be the same. So I'm going to keep the rest of them the same. Okay, so you can see I tried to keep these the same. I mean, it's not exactly the same from my drawing, but I try to keep them the same. Now, the only two sides, these two sides went inward, right? So this is what I mean by concave, is that this angle goes in, this side goes in, which means that this angle right here ends up being greater than 180. So this is another way to think about it. If this angle is bigger than 180 or a reflex angle, that means you have a concave shape. A really good example of this is a star, right? If you think of a star, it has 10 sides. It's a decagon, but it's a concave decagon. So that's another example. But now, let's talk about the difference between regular versus irregular. We mentioned briefly what regular meant. So regular, again, means that the sides are all congruent. So imagine these sides are all congruent, and the angles are congruent. So in other words, it has to satisfy two conditions. It has to be regular, or I'm sorry, for it to be regular, it has to satisfy two conditions. It has to be equiangular, and it has to be equilateral. All right, so equiangular means that they all the angles are congruent. Equilateral, all the sides are congruent. Okay, so an irregular shape would just be something that's not that, right? So just imagine the same thing. Okay, so imagine something like this, right? 1, 2, 3, 4, 5, 6 sides. So it's still a hexagon, but it's not regular. The angles are not the same, and the sides are not the same, okay? So this is an example of not, it's neither, right? So it's neither equiangular nor equilateral. But you can have a situation where you're equiangular but not equilateral. So for example, if you look at a rectangle is equilateral or equiangular but not equiangular, or equiangular but not equilateral, right? So this is another example of irregular. So I'm going to say not equilateral, but it is equiangular, right? So these are two examples of irregular. All right, so now that we know that, so we know what irregular means and irregular, we know what convex means. So we can only use this for these shapes, convex, okay? And we know that the angles add up to 360. All right, so let's look at example 4, find missing values. So for this one, we have exterior angles. We have 4 exterior angles. So we know that they have to add up to 360 according to that theorem. All right, so let's write down the rest of the exterior angles. So we got 139, and we have 9x. All right, so combine your like terms here, and we'll show our work over here. So we got 6x plus 2x plus 9x, that's 11, 17. So we got 17x, just showing my work here, plus 139 equals 360. And then we'll go ahead and subtract that over. We got 221 divided by 17. We got 13. And there's my answer. All right, go ahead and do the check below, pause the video real quick, and see if you can answer the question. All right, so again, so 1, 2, 3, 4, 5, there's 5 angles here. So we're going to add them up and set them equal to 360. So we'll do that over here. So we got x plus 2 plus x plus 10 plus 88 plus 2x plus 52 equals 360. Are we going to combine our like terms? So 1, 2, 3, that's a total of 4x, and then we're going to combine these two numbers. So we get 4x plus 152 equals 360. We're going to subtract 152 on both sides. And again, I'm not going to show that just because I'm out of room here. Then subtract 152 from 360. And then divide by 4. So 4 goes into 208 52 times. And there's our solution. Okay, and we're going to wrap up with we're going to do the last problem here, example 5. Now this time we're finding exterior angles for a regular polygon. All right, so let's do that. We know that for any polygon, for any convex polygon, the exterior angles add up to 360. Now, if the polygon is regular, that means we would expect all of these angles to be the same, right? So we could just take the sum of 360 and divide by how many of them we have. So, in other words, if I have if I have a situation where I have a regular. Okay, so for example, if we had a hexagon that looks like this, where it's all congruent, right? All these are congruent, and that means if I were to draw the exterior angles, that means all of these exterior angles are going to be congruent. And so I would take the sum of all these, which is 360, and I would divide by 6, right? Because I have 6 of them that are the same. And that means each of these are equal to 60 degrees. And that's really all there is to it. So the formula for each exterior angle in a regular polygon, of course, it's got to be a convex polygon, so let me include that. Regular convex polygon is as follows. It's x equals 360 divided by n, where n is the number of sides and x is the angle, okay? So this is the formula that we want to use. All right, so here we go. So we have 12 congruent sides for dodecagon, so that means we're going to divide by 12, right? So let's go ahead and do that. If we know that x is equal to 360 divided by n, right, if I use that formula, but we know that n is equal to 12, so divide by 12. So in other words, what we could do is if we move this 12 over here, then we just get 12n. In this case, they said n is my x, right? N is the measure. So it's a little confusing, but I usually stick to the same variables. X for me is the angle in degrees. N for me is the number of sides, and I keep that consistent throughout. The book doesn't necessarily keep that consistent throughout, because in here, in one of the other formulas, n stood for the number of sides, but here now n is the measure of the angle, okay? But just keep that in mind. But in any case, we know that the angles add up to 360, and we have 12 of them, so it's 12 times n. But we divide by 12 on both sides, and that gives us my formula, okay? So we had 360 divided by 12, which is right here, and that will give us 30 degrees. And that's, each of the angles is 30. All right, so go ahead and pause this real quick and do the last problem. Okay, so the measure of each exterior angle of a regular octagon, we have 8 sides, so n is equal to 8. So that means x equals 360 divided by 8, which is equal to 45 degrees. And that is all there is to it. All right, guys, that's going to do it for the lesson. I hope you found this useful and informative, as usual. I'll see you in the next one.